F big G is equal to G times M2 times M2 over R squared. And big G, universal gravitational constant, is equal to 6.67 times 10 to the negative 11. And then if you remember the units, Newton meters squared per, pardon me, thank you, kilograms squared. I am blessed. All right, so we got a couple of masses side by side here. And what we could say is that if I have mass on one side and mass on the other, I'm just going to write them both as lowercase m to indicate that they're the same value, the same mass that's present. Let's just say that those two masses experience a mutually attractive force when their centers are r apart. They would experience a force of Fg. If I take one mass, keep it the same mass, but I double the other mass, and I keep them the same distance apart. In fact, all of these examples are the same distance apart, same R value all the way down that column. What would be true about the force? How would it compare to the first one? I doubled one of the masses. What's gonna happen to the force? We're looking at the proportionality statement up above. It's going to increase, yes. Does anybody know exactly by how much? Look at the equation. I double one of the masses. What happens to the force? Come on. It doubles, yeah, absolutely. He's got it. All right. How about this? We swap the masses out again. This time one of the masses is 2m, the other one is also 2m. What does that do to the force of attraction between these bodies as compared to the first one? What do you say? 4 times, 100%. Yep. See, I'm not trying to trick you. You think it's too easy. What about this? What if I make it be, now this actually feels like it's a little bit tricky. If I have one be a massive m, but the other one be 3m, in other words, the last system in my column is the same mass in total as the second last system in my column. What's the attractive force for this one? I know it's because it's morning. You can show me fingers. What do you say? Three fingers. All right, 3 fingers in the morning. There you go. 3FG. All right. All right. So if we mess around with the masses that are present, this is just proportionality, right? And this is something that in grade 11 sometimes people get messed up on. If I start with the same two masses as I did in the previous scenario, m and m, it's like the candy shop, separated by a distance r, then I'm still going to have a force of gravity, Fg. What if I take the same two masses? So mass is a control variable this time, but I change the r value. This is my independent variable now, and I make my independent variable r into 2r. I double the distance between them. What happens to the Fg value? It doesn't half. Look at this equation here. What happens if you double the r? Look at this. If it's 1 over r squared as opposed to 1 over 2r squared, what happens to the Fg value? Can you show me with fingers? I saw a 4. It doesn't quadruple. What is it? All right, let the record show I got people putting a 1 up and then underneath of it 4 fingers. I guess that's how we do fractions with fingers. That's fine. So 1/4. You guys are so shy. Is it because of my intimidating voice? It's all right. All right, quarter Fg. Let's say we take the r value down not to even r anymore, but we take it down to a half r. Keep the m's the same. Remember, that's the control variable, half r. Think about what we said here with the pattern. What happens to the relative force between those as compared to the original force? Think about how you'd Process this one. 1 divided by a half r squared. Yeah.
Would it double?
Doesn't double. You're on the right track. Doesn't double though. You can show me with fingers. All right, got a whole bunch of people putting up 4 fingers. It does. It quadruples. And if you're not quite sure of why it quadruples, remember 1 over a half r squared is equal to 1 over 1/4. Take away the brackets because I square what's inside the brackets. 1/4 r squared. That 1/4 inverts and multiplies and becomes a multiplier of 4. Okay. I mean, you can try it. 1 divided by 1/4 though is 4. Definitely. Okay. So we get 4 FG. This is just playing around with the proportionalities. Now, if I mess around with both what's going on in column 1 and what's going on in column 2, because I think we get the pattern here, and I say, hey, I'm going to knock this guy up to 2m. I'm going to knock this guy up to 2m. And I'm going to separate those two masses by a distance of 2r. Just double everything. More of everything. What does that do to the FG? Let's think about it. I doubled both of them. That's going to be a quadrupling effect. I made them twice as far apart. That's going to be a 1/4ing effect. What's the net effect? Yeah, 4 times 1/4 is 1, right? Look at that. If I take twice the mass and I separate them by twice the distance, it just comes back to FG again, okay? And so this little mini lesson isn't really about new concepts or anything. This is just about playing around with proportionalities, something that I find that sort of washes over people a little bit in grade 11. And maybe it did wash over you, and that's why it's like a little bit quiet this morning. Or maybe it really is the intimidation of my voice in the morning. I don't really know. But hopefully that makes sense.